Hello, fifth graders. It's Mrs. Tremblay. We are starting Unit 4, and Unit 4 is multiplying and dividing whole numbers. So this says Packet 1 because this has all the multiplication part in it, and then you'll get another one that has division after, but 15 pages is enough. So hopefully you have numbered the pages in your packet, and we're going to look at pages 1 and 2 today for Lesson 1. We might do Lesson 2 as well, see how it goes time-wise. All right, so we're coming back to our place value chart here, and you can see I have a whole bunch of 4s here, and I'd like us to start by putting our commas in. And to remind you that this is every 3, right? So we start all the way in the 1s, and then every third spot, there's a comma in between. So 1, 2, 3, comma, 1, 2, 3, comma. And this number here would be read 4,444,444. And here I have the actual value of the digit. So because this 4 is in the millions place, that means it is worth 4 million, a 4 with 6 zeros. And because this 4 is in the hundred thousands place, this 4 would be worth 400,000. This 4 is in the 10,000s place, so that's worth 40,000. And 4 in the thousands is 4,000, and 4 hundreds. And 4 tens would be 40, and 4 ones would be 4. So the first thing I'd like to review with you is the fact that each place is 10 times the value of the place to its right. So for example, a 4 in the tens place is 4 times greater than the 4 in the ones place because the 4 in the tens place is worth 40 and the 4 in the ones place is worth 4. So 40 is 10 times greater than 4, as 4 times 10 is 40. So right here it says, every time you multiply by 10, the digit shifts one place to the. And we'll fill this in 1 second. So right here, I have 4 to 40, right? And we just said that to go from 4 to 40, this 40 is 10 times greater than 4. So 4 times 10 is 40. Now that same thing happens from 40 to 400. If you multiply 40 by 10, you're going to get 400. And if you multiply 400 by 10, yep, you're going to get 4,000. And if you multiply 4,000 by 10, you'll get 40,000. And the answer to should we be writing this is yes, you definitely should. So every time we shift one place to the left, it gets 10 times greater, right? Now notice it says here, every time you multiply by 10, the digit shifts one place to the. So here it's 4, right? When you multiply 4 by 10, this 4 was in the ones place. It shifts one place left to the tens place. And then this was in the tens place. When we multiply by 10, it shifts one place left to the hundreds place. And then one place left to the thousands, and then 10,000s and hundreds and millions. So every time you multiply by 10, the digit shifts one place to the left. 10 times 10 is 100, right? So when you multiply by 100, that's the same as multiplying by 10 twice. The digit ends up shifting 2 places to the left. So for example, if I multiplied 4 by 100, that 4 shifts 2 places. It goes from the tens to then the hundreds. And that's because multiplying by 10 twice is the same as multiplying by 100. If we multiply by 10 3 times, notice that 4 moves to the thousands place from the ones place. That's because multiplying by 10 3 times is the same as multiplying by 1,000. So when you multiply by 1,000, it's like multiplying by 10 3 times. The digit shifts 3 places to the left. So big picture here, I want you to understand that multiplying a value by 10 shifts the digit one place to the left. And notice we have a whole bunch of zeros after that shift, right? Did you notice when we multiplied by 10, we had a 0 after that 4? And when we multiplied the 400 by 10, we had another 0 and another and another. That's the pattern we're going to look at today that's going to be really helpful. So patterns in multiplying with zeros. Okay, so we're going to start off with just 2 times 3. And 2 times 3, that's 6, right? That's one that we know. Now, 2 times 30, you might not know. And let's review what could we do to figure out 2 times 30? Well, we could add 2 30 times, right? And count by 2 30 times. Or this means 30 twice, right? So we could do 30 plus 30, and 30 plus 30 would give us 60. The same thing here with 2 times 300. This means I have 300 plus another 300. There's 2 of them. So 300 plus 300 is 600. And if I have 3,000 times 2, that's the same as having 2 3,000s that you add. And if you have 3,000 and another 3,000, that means you have 6,000. So I'd like you to pause for a moment here and take a look at these and see what kind of patterns you notice with the zeros, patterns in multiplying with zeros. So pause this and take a moment to discuss this as a class, and then press play when you are ready. Okay, welcome back. I'm hoping that maybe we noticed that with these, we multiplied our digits, right? 2 times 3 is 6. And in this one, 2 times 3 is 6. And 2 times 3 is 6. And did you kind of notice that however many zeros I had here, or how many zeros were after the 2 times the 3? So here 2 times 3, and then I have 2 zeros, 2 zeros. 3 zeros, 3 zeros. Yeah, so that's the pattern. So basically, if we wanted to multiply, and we saw that we were multiplying by a number that ended with a bunch of zeros, okay? We call those multiples of 10. You can basically multiply the non-zero digits that just means the digits that aren't 0. Like in this one, 2 and 3, there's no 0. Here, 2 and 30, the non-zero digits would be the 2 and the 3. And here, 2 and the 3, 2 and the 3. The rest are zeros. So your step 1, we can just multiply the non-zero digits, and then you add in the number of zeros in the problem after the product. I'm going to use a number sign. You call it a hashtag, I call it a number. Add in the number of zeros in the problem after the product. So meaning the product you just got. That's kind of what's happening here, and that happens when you multiply by multiples of 10. So what I mean is, you multiply the non-zero digits, 2 times 3, and then we look at how many zeros are left over there. 1, 2, 3. There's 3 zeros, so I put 3 zeros after the product I just got when I did 2 times 3. So let's try some. So turn your page, you're on page 2, and it says use the pattern to help you solve these problems. So we're going to use what we just saw. Now, with 40 times 3, we know we could do 40 plus 40 plus 40, okay? You could do that, but we just saw the pattern that when I'm multiplying by a multiple of 10, by a number that ends in 0, that's how you can tell it's a multiple of 10, I can multiply the non-zero digits. So in this case, I would do 4 times 3. That's 12. And then I include the number of zeros in the problem after that product. So do you see how there's 1 0? I'm going to put that after my 12. We get 120. So if 4 times 3 is 12, then 40 times 3 is 120. The reason this works is because 40 is just like 4 times 10. Should you write that? Yes, you should. So 40 is just like 4 times 10, and then I'm supposed to multiply that by 3. And you learned about the commutative and associative properties. We learned that when you multiply numbers, the order doesn't matter. I'm going to make these little X's just so you can see its multiplication. That means that I could do 4 times 3, which is 12, and then multiply 12 by the 10. And we know that when you multiply something by 10, that shifts the digits one place left. So we're shifting the 12 one place left. And when you shift the 12 one place left, we need a 0 for that placeholder. So it all kind of ties back. All right, so for letter B, I'm going to multiply my non-zero digits. 3 times 6, that's 18. And then I have 2 zeros. That means it's like multiplying by 10 twice. So I'm going to shift 2 places. That means I need my 2 zeros. So 1,800 is what you should have. For letter C, I have 7,000 times 8. I'd multiply my non-zero digits. 7 times 8 is 56. And then I have 3 zeros. Letter D, 600 times 900. So why don't you go ahead for these and pause and try it, and then press play after each one to make sure that you're right. Don't try all of them. I want to make sure you're on the right track, so one at a time. So you do 600 times 9, press pause, and then press play when you're done. All right, so 6 times 9 is 54, and then there are 2 zeros, so I put my 2 zeros, and I'm going to add in my comma, 1, 2, 3, 5,400. All right, same thing, press pause, try it. Press play when you're done. Okay, welcome back. 4 times 4 is 16, and with this one, I see 2 zeros. So we would put 2 zeros, 1,600. So again, you're multiplying the non-zero digits, and we put those zeros in after, because this is like saying 4 times 10 times 4 times 10. 4 times 4 is 16, and when you multiply 10 by 10, it's 100. So 16 times 100 is 1,600. All right, try letter F. So press play when you're ready. 4 times 3 is 12, and then I see 1, 2 zeros, 1, 2. So 1,200. Letter G, press pause. 3 times 6 is 18, and then there's 1, 2, 3 zeros. I put in my comma, 1, 2, 3, 18,000. Letter H, press pause. 7 times 8 is 56, and I see 1, 2, 3, 4, 5 zeros. 1, 2, 3, 4, 5. We put in our commas. Yes, you need to put in those commas. 1, 2, 3, 1, 2, 3, and this would be 5,600,000. Okay, letter I, press pause. 6 times 9 is 54, and there are 1, 2, 3, 4 zeros. 1, 2, 3, 4. We put in our commas, 1, 2, 3, and we get 540,000. And letter J. All right, try this one. This one looks a little different. Press play when you're ready. All right, 12 times 2. Those are my non-zero digits. 12 times 2 is 24, and there are 2 zeros, 1, 2, and put in your comma, 1, 2, 3. 2,400. So basically, if you see that you are multiplying by a multiple of 10, and to tell that it's a multiple of 10, it ends in a 0. You can multiply your non-zero digits, and then however many zeros are in the problem, that's how many zeros are in your product. Not because it's magic, but because this is like saying 6 times 100. And 100 is the same as multiplying by 10 twice. That means we would shift over the 54 twice. We'd need 2 zeros for placeholders. All right, thank you so much for watching. I miss you guys.